You know, in the cloud, everything is about speed. But here's the billion-dollar question. How do you move fast without, breaking things? It's this constant tug of war, right? Trying to keep everything secure and under control without slowing everyone down. Well, today we're going to dive into how you can solve that exact puzzle on Google Cloud using a really powerful idea called policy as code.
But first, just think about your own team for a second. Seriously, who actually gives the final sign-off on your infrastructure code before it hits production? Is it an architect who's already swamped on a Friday afternoon? Are you just running through a static checklist? Or, let's be honest, maybe nobody is. For a lot of teams, this is a huge blind spot, and it's exactly what we're here to fix.
And that really gets us to the heart of the matter, what I like to call cloud governance chaos. You've probably seen it. It's that state of things where all the rules live in different places. Some are in a wiki, some are in a spreadsheet, and the rest just rely on manual reviews. It's not just slow and inconsistent. Frankly, it's pretty dangerous.
I bet this list looks familiar. We've all heard the horror stories, right? That one storage bucket that gets accidentally set to public and suddenly sensitive data is all over the internet. Or that firewall role that's just a little too open, creating a perfect backdoor. These aren't just hypotheticals. These are the real, high-stakes consequences of trying to do this stuff by hand.
So, how do we get out of this mess? The answer is to completely change how we think about the problem. We need to stop relying on manual checklists that happen after the fact and move to something that's automated and proactive. And that, right there, is the entire promise of policy as code.
Okay, so what exactly is policy as code, or PAC? It's actually pretty simple. You take all your rules, your security policies, your compliance requirements, all of it, and you write them down as code. The best analogy I've heard, it's like having a spell checker, but for your entire cloud infrastructure. It just automatically flags anything that doesn't follow the rules.
And wow, when you put it side by side like this, the difference is just night and day. The old way is a total bottleneck. It depends on people, and people get tired, they make mistakes, it just can't keep up. The new way? With policy as code, it's instant. It's 100% consistent every single time. And it scales perfectly as your company grows, no problem.
All right, so the theory sounds great, but what does this actually look like on a real project on GCP? Let's walk through what happens during a totally normal day when an engineer makes a change using a tool like Terraform. First, let's look at the tools you've got. Think of GCP's organization policies as these big, high-level guardrails for your entire company. Then you have IAM conditions, which let you get way more specific and granular. But the real magic, the engine that powers all this automation, is something called Config Validator. It uses an awesome open-source standard called Open Policy Agent, or OPA, to check your code right inside your development pipeline.
Okay, so let's follow the code. An engineer needs a new storage bucket. They write up the Terraform and they commit it to Git. The second they do that, an automatic pipeline just springs to life. It fires up Config Validator, which instantly compares the code to your policies. Is public access disabled? Yep. Is our mandatory encryption turned on? You bet. If it's all good, the change gets approved and applied. But if not, it's blocked right then and there with a clear message explaining exactly what's wrong. No human review needed, it just happens.
So what do you get for setting all this up? What's the big payoff? Well, it really boils down to 3 huge wins: automation, auditability, and assurance. First up, automation. I mean, this is the big one. Your security rules, your compliance rules, they get checked on every single change without fail. This completely frees up your senior engineers from doing boring, repetitive code reviews and lets them focus on much bigger problems. And of course, it just gets rid of human error.
Second, auditability. This is huge. Because your policies are just code living in Git, you have this perfect, version-controlled audit trail. When an auditor comes knocking and asks, "Hey, what was your policy on data encryption 6 months ago?" you don't have to go digging through old emails and documents. You can just point them to the exact line of code. It's clean, it's precise, and it's undeniable.
And finally, all of this gives you assurance. It's that peace of mind you get from knowing you have these automated guardrails protecting your environment 24/7. You can be confident that your cloud is compliant today, and maybe more importantly, that it's going to stay compliant tomorrow.
Now, I know this all sounds really powerful, but it might also seem like a massive project. But here's the good news. You don't have to do it all at once. In fact, you shouldn't. You can, and absolutely should, roll out policy as code one step at a time.
Here is a simple 5-step plan to get you going. First, just start small. Pick one important, high-impact rule that's easy to define, like no public storage buckets. Second, write that rule as code using a language like Rego for OPA. Third, and this part is so important, put it in your pipeline in audit mode first. That means it'll just log any violations without actually stopping the deployment. It lets you test everything safely. Fourth, once you're happy with how it's working, flip the switch to enforce mode. And finally, just iterate. Add the next policy and then the next one, and slowly build up your automated safety net.
So, that's the whole shebang. We've seen the chaos that comes from manual governance, and we've seen the clean, elegant solution that is policy as code. You've got the toolkit for GCP and a clear, practical path to get started. So really, there's only one question left to ask yourself. What's the first rule you're going to write?